All right, then hi and welcome from my side to the talk on service meshes, enterprise Java, Kubernetes and Istio and all these things. I'm very happy to be here. This is actually my very first time in Riga. And yeah, a little bit about myself. My name is Sebastian Daschner, born and raised in Munich, Germany. And I work for this company called IBM, and I do a lot of things on Java side. So typically it's enterprise Java or enterprise software in general, a lot of titles that you can read here and stuff like that. And another interesting fact about myself, I love coffee. So today what I'm going to show you, have some live coding examples because I believe, live coding and live demos is a little bit more interesting than reading just slides. And I'm going to have some enterprise coffee for you. Some microservice example, quote unquote, where I'm going to use enterprise Java. So Jakarta EE, microprofile, and a few things of that. And we're going to deploy that in a modern environment using cloud native technologies. So we're going to have a look at Docker, Kubernetes, and then of course service meshes and Istio. And we're going to look a little bit into the question, why should enterprise developers care about these technologies? So that's going to be the deal. So here's a quick question for you. Who of you is familiar with containers and Docker? Hands up. Okay, that's almost everybody. Who knows about container orchestration and Kubernetes? Okay, a lot of people, that's good. And who has played around with service meshes and Istio and these things? Okay, good. Okay, so we have a quick look into all these things, especially also into Kubernetes. Of course, you can ask questions. They are highly welcome. And other than that, let's look a little bit into this example that I have. So imagine we have two applications. One is called Coffee Shop and the other one is called Barista. So if you want to have a coffee, so as a client, you go to the Coffee Shop application and then you would talk to the application, have something like order coffee. That might be an HTTP call, might be any type of communication that you do with that system. And then now in our case, to have some communication inside that cluster, what we're going to do is have a synchronous call, just for the sake of the example, by doing something like start the coffee brewing process. So that's going to be a synchronous call, HTTP in this case, where we're going to call that system. All right, so let's look a little bit into the code. I'm going to use Enterprise Java here. I use Maven to build, these two projects. So I have two projects, Coffee Shop, Barista. They're totally independent. That means independent projects, they're going to be run on, some application container, and they're going to be deployed as individual containers, or later on, Kubernetes pods and all these things. So I'm going to build that with Java EE 8 plus some microprofile additions. I'm going to show a little bit of that later. And then, just because I'm brave, I'm using Java 11 already. Who of you uses Java 11 or 12 in production? Hands up. Even a few. That's good. Who of you uses Java 10 or 9 in a production? Okay. Who of you uses Java 8? Okay. And who of you doesn't use Java at all? Okay, so a lot of Java folks here. And yeah, Java 8, this is what we are still doing, right? But this example, and it will work, uses a little bit newer technology. And then let me quickly walk you through the code, just that you see what's going on here. It's not necessarily only about Java code, because we're going to show a lot of cloud native things here today, but just that you see, what the code looks like from a Java perspective. So we're going to have a JAX REST resource, standard for REST services, right? HTTP. That means we're going to have a URL later on, something like, resources/orders in our case. That means we can have coffee orders and then, the typical REST stuff like get some orders, post a new coffee order with a JSON in this case, if you like. And in order to create a new coffee, because this is what we want to do, we're going to call this method. So that method is annotated with post. We can post some coffee here. And let's quickly step through the business logic, quote unquote. We're going to have a class here, a coffee shop, where we can order some coffee, right? And the main important thing of that business logic is, as you can see in the diagram here, it wants to talk to the other backend, the Barista backend. So we have something like a Barista component here, which is basically an HTTP client, right? Like a gateway class or something. So we can use an HTTP client, such as JAX REST client, to access this. And that means, well, we're going to make a HTTP put request and do some stuff with that URL and so on and so forth. And that's basically it. That's basically the workflow of ordering a coffee. All right. Now, if we go and take that, what we could do is, well, we built that project. I'm using a thin WAR deployment artifact approach. And then we could deploy that to some, Java EE compatible application container. But that's pretty boring, right? It has been done for years. What we could also do, we're going to take that and run it as Docker containers. And if you're familiar with Docker, and you are, so you know, we're going to need something like a Docker file, right? And luckily with Java Enterprise, that comes very handy. That's actually pretty easy to define because of that way of separating the business logic from the implementation. All we need to do is provide something like a layered approach, a base image, that already includes everything we need from the application server side, right? I use OpenLiberty in this case, so we can add an OpenLiberty application server. We need to add Java, right? And maybe some other configuration. Here I have some optional server configuration, and then finally we add our application. Put that all together and ship it, well, as a Docker image. Then we can take that image and run it, right? We could run that locally, but again, that's kind of boring. What we actually want to do, I talked about container orchestration before. We want to run this in a Kubernetes environment or in a container orchestration environment. Why? Cloud native technology. So if you ever try to run Docker containers in a production-like setting, you would notice it's quite an effort to set up all, these networking and stuff around to manage all these containers, right? It's not just enough to start a container somewhere. You have to define network. You have to define some IP addresses. If you have multiple machines, right, they have to communicate and all that stuff. And what happens if one container stops working? So luckily, there are a few frameworks around that. For example, Kubernetes, most famous one, production-grade container orchestration. It orchestrates the containers for us. And then we have a few things defined. For example, this is how that roughly might look. Our example, we have things like services, right, or pods. So what is that? A container orchestration, a Kubernetes service, is basically an abstraction over our application, right? If we have a coffee shop, microservice or service, then we will have a Kubernetes coffee shop service. Same for the barista one, another barista service, right? These services might have multiple instances. So we might have 5 or 10 or 2 or 1 running containers, running pods, that's the name in Kubernetes, that actually implement these services, right? And the way how we define this, so the good news about all this cloud native technology, same with Docker files, is infrastructure as code. We don't have to go and manually do some processes on an environment. For example, execute some SSH commands and stuff like that. This is cumbersome, this is repetitive, this is actually error prone. What we do instead, infrastructure as code, we define as code, for example, in a Docker file, the state, the way how our environment is supposed to look like later on. So here in the Docker file, we define how that looks like, how a single application, what it needs in order to run. What makes that very application, that coffee shop. And now in the same way, in a Kubernetes environment, what we do, we define the same way in a declarative approach, what, pods and services and all that we have. So this is a YAML file format. Who of you has seen that? Who of you knows about the YAML file format? Hands up. Oh, a lot of people. Who of you likes the YAML file format? Hands up. Oh, at least 1, 2, 3, a few fans of this. Well, we're going to talk about that. What we define here is Kubernetes resources, for example, a service. So that is that service abstraction. And then we define some pods, but not directly, but in another abstraction that is called deployment. Because we might have, multiple instances, multiple coffee shop pods or something like that. And that's then easier to manage. So we simply say, well, we're going to have a template, like a blueprint or a template of how we create pods. And then please create so and so many pods according to this template, in this case 1. So we're going to have 1 replica of whatever I define here, right? All right, that's easy. Same for barista. So we're going to have a service, barista has a name and so on and so forth, and a deployment. Totally independent, does a few things, right? And then what we do in our environment, basically if a client call comes in and wants to order a coffee at the coffee shop, it will be routed to, well, one of the running instances. And in the same way, if the coffee shop application needs to access a barista application instance, well, it will do so actually using that barista service, and then the same thing back. So in case you ask yourself, well, how does the coffee shop application actually find the barista application? That's an interesting story, right? Because in the past, we wouldn't have need to configure IP addresses, right, or DNS names for the test environment, for a staging environment, for a production environment. Same with databases, right, or anything external that we want to access. We need to reconfigure that depending on the environment. So here in a Kubernetes environment, we have actually a nice way of doing that so that we can avoid this configuration. And you've probably seen this URL before. So this is how we access the barista backend. We simply say hostname barista, port 9080. That's the default port for Liberty. That doesn't matter. So where does that come from? That's actually the Kubernetes service name of the barista service. So Kubernetes does a cluster internal DNS resolution where we can simply call this URL or access this URL and then resolve that host name and end up in one of the running instances, which is very helpful for us because no matter in which environment we're in, test environment, staging environment, production environment, we can always just specify that name, barista. I don't care where I run, just give me one barista instance, right? And then Kubernetes will resolve that accordingly. And then we can literally hard code that URL and it will just work. So this is a nice story of the Kubernetes resolution here. And that's about it. Okay, so now enough talking. Let's see some demo of that. What I'm going to show, I'm going to deploy this to a Kubernetes environment running in the cloud. So you can, host such an environment almost anywhere that you like. You can set it up on your laptop using virtual machines. You can run some cloud environments. This is what I use. That's the IBM Cloud with a managed Kubernetes service somewhere in Frankfurt or something. And we're going to access that. So once you have access to a Kubernetes service, we can use this kube control command line tool to talk with our cluster, to take these YAMLs and throw them against the cluster, right? So we can have things like kube control, give me these services in my cluster. And well, hope that the network works. You see, well, there's not much there. Give me the pods. Well, it's basically empty. That cluster is empty, let's change it. Let's deploy something. Our coffee shop deployment, all these YAMLs that I just showed you, and the same is true for the barista service. So we're gonna deploy, services and deployments and a bunch of other things for our two microservice examples. And what that means is that now, just like in the diagram, we created the coffee shop service and the barista service and deployments for these. So we now have running instances. And that means once that is up and running, we can actually access our application here. And then finally, order some coffee. So what we do here, let's see whether that is up and running. We see the status here of that application. And then we can use any HTTP client, because I'm still talking HTTP, of our choice to access that cluster, right? So I'm a command line fan, I use curl. And then I'm gonna have a magic script to get the IP address of my cluster. And then let's see, coffee shop resources. So coffee shop is the context path. Resources comes from JAX-RS. And you remember orders to access my application and to ask for the coffee orders, HTTP GET. And good news, 200, okay, and it's empty. Well, empty JSON array. All right, let's change this. Let's order some coffee. How do we do that? Let's have a look at this coffee order. This is basically serialized using JSONB. It's all Java Enterprise Standard technology, and we have basically a coffee order with a coffee type, like cappuccino, espresso, things like that. And what we're going to do is post some application JSON to this resource, for example, type. And let's say we have some espresso. All right, agree? Okay, let's do this. We post some espresso. We finally want to order some coffee. And good news, 201 created. Great. We have a new resource in our service. And hopefully that means, yes, we see something here. We're going to have an order in our system. Great. All right. Now that means it works, right? Ready for production. No? Why are you laughing? It works. If we have a look at our diagram, at this one or this one, we can see, well, apparently I called the coffee shop service, and that is communicating with the barista service, right? So apparently that works. And if we have a look at our code, we also see, well, this is being called in a synchronous context, in a synchronous thread, and ends up at that HTTP call to barista. So it works. But yeah, it's maybe not quite ready for production because there are a few things lacking, actually. So for example, proper observability. We don't really know what's going on inside there. I mean, I ordered some coffee, I fired a request, and I got the order back. But that doesn't mean that everything works internally. Or maybe some more resiliency. What happens if something goes wrong, if the barista backend is unavailable, and stuff like that. So luckily for that, we're gonna have a look into service meshes. And what I actually have here in my environment, it's not only a Kubernetes cluster, it's actually also a service mesh, an Istio cluster, an Istio service mesh. So what is a service mesh? A service mesh is basically a mesh of interconnected microservice deployments, like multiple microservices that run, where we can add some more cross-cutting concerns, some more concerns that we might need in production without changing the application. So that's the interesting thing. That means we can add things like observability, resiliency, more advanced traffic management. I'm going to show you all of that without changing what's running inside. So inside there, it's still the plain old Java Enterprise application that runs in my Liberty. But what we can do here is actually, and I'm going to order more coffee, we can have a look at all the observability that's being provided by Istio out of the box. For example, monitoring, tracing, and a few other things. So let's order some more coffee, more coffee, more coffee, more coffee, to have a little bit more traffic in our cluster. And then what we do, we're going to have a look at this one. This is Grafana. Grafana is a, now I probably need to restart my, port forwarding because of the network reset. Now it works. Grafana is a monitoring technology where we can have things like technical metrics that are actually provided here out of the box. So you can see we have a coffee shop service here and the barista service. Now I didn't set that up. I didn't configure that. That is being provided out of the box by a service resolution in Kubernetes, and the Istio components know about the services there. And we see, oh, we have actually some traffic in our barista application. And success rate, request duration, things like that. And the incoming traffic, oh, that comes from the coffee shop service actually. And that's to tell us that actually now we have some traffic from the coffee shop to the barista service. Okay, that might already be helpful. Good news is we don't have to configure that here. Another thing is, is this cute little guy with the German name Jäger, means hunter. That is a distributed tracing technology. And with that, we can trace individual requests where they actually go through in our system. If we have multiple instances of our service, which instances are actually involved for particular requests. And here we can have a look at, the latest request that went through, well, the cluster basically. And what we can see here is we have a synchronous request, or a synchronous outgoing request into the ingress gateway that ends up at the coffee shop application, and then now synchronously that calls the barista backend. Can actually have even a look at all the information here. So this looks familiar. We have a put request to that URL, and we see where that's going through, how long it takes, and so on and so forth. And just that information, that is a synchronous request here. Another interesting technology is this one. You might have seen that before. That's Kiali. Kiali is, well, a service graph technology here. Let's zoom that in. And it shows the graph of our involved applications, like coffee shop and barista, and where the actual communication is happening. So we're gonna have a fancy traffic animation here. Oh, great. So we're going to see that actually the coffee shop application is called the barista application. And this only shows where we actually have some communication. So even if there were some other code involved that's currently not being called, then we would not see that. And yes, I know that's kind of boring because it's only, 2 applications and it's only 1 line. But you can imagine if we have a more advanced example of multiple services, this can be quite helpful to have an overview, okay, what's actually going on and which one is involved. So now you might ask the question, how does all that magic work, right? Without providing anything from our application, we literally just do an HTTP call. How does Istio know about all that stuff? So the way how that works in a service mesh environment, our application here, remember before we had pods, and a pod contains a running Docker container or any running container. Now we have a service mesh here, where we also have services and pods, but each and every pod now contains 2 containers, our main container, our application container, and a sidecar container, proxy container. That's an Envoy proxy under the hood, and that actually, manages all that stuff for us. So what it does, if we have a client call to that coffee shop service, for example, that call actually ends up at the proxy. And that proxy will or might forward that request to the main container. And in the same way, if the main container does a call to the other system, it also, goes through the proxy and ends up at the other proxy, and that calls that container and the whole thing back, right? So you can see that all of that communication happens through these proxies. And then you can imagine, actually quite similar to Java Enterprise or Spring, how these proxies work on a Java level. Well, now here we can have the full information and see what's going on in the system, and also have the full control over all of the communication, right? And then in another way, we can have, some communication from what is called a control plane that comes from Istio, and that basically talks to all of these proxies individually and can reconfigure them and can gather some information. So this is how we get all the information for monitoring and tracing, because, then we see all of these requests which went through the proxies. So that's quite helpful. But that doesn't answer one question. How does the tracing work, right? Because we have, we can see all of these requests. Yeah, that's true, that's cute. But how do we actually know that these 2 requests, these are just individual HTTP requests, right? That they're actually correlated just because they happen to happen at the same time, right? Because that's one request that goes into the coffee shop, and then we have another HTTP request that goes to the barista service, right? So what that means, as you probably know, we need some correlation IDs. We need some way to correlate, to tell the system, hey, these 2 are actually connected, or in other words, one originated from the other. So in order to do that, there is actually a way to specify that in Jaeger or Zipkin or Open Tracing to provide HTTP headers, for example. And there is a way in the Istio documentation how to do that. You might have seen that, the HTTP headers like x-b3, span ID, trace ID, things like that, which we obviously need to provide in our application. So that is something actually the application has to do. Why? Well, because only the application knows that this is actually a synchronous request that goes in and ends up at the HTTP client, right? So this one originated from the other one. So in order to do that, you can see some examples here. That's also using JAX-RS. What we would need to do is, take all of these parameters, all of these headers, and then, pass them into a client response. So in our case, that would mean we go to the orders resource. We are right here. We would need to extract all of these HTTP headers for the tracing context. Then we would pass them here. We will pass them here. We would pass them here, extract them here, and send them to the HTTP client, right? Cool. That would be kind of cumbersome. That would be kind of bad, right? Just loading up our code. Or at least what we could do is having some kind of tracing context object that we could inject and store it there, but still a lot of boilerplate code. Luckily, we don't have to do that in Java Enterprise. What we can do is use a Java EE extension with microprofile, a project called microprofile open tracing. And what that does, among a few other things, it's actually providing a Java API to control what we trace here, which we actually don't have to use. So what I'm doing here in my POM file, I don't even import that microprofile open tracing, but what I do, I let my runtime know that now I want to use this open tracing stuff. And what it does, if we have a JAX-Trace resource, like this one, where we will receive an HTTP request with all this information, then automatically it will take that information and store it locally. And if in the same synchronous execution we have a client here and a client JAX-Trace client request, then it will take that information, pass it to the client request, and send it along automatically without any involvement on our side, which is great. So we don't have to do anything here. The only thing what we have to do in our case, depending on the application server, is letting it know how to configure that. Let's use the other one that's smaller. So that is, now this is Open Liberty specific, the application server I'm using. And that means we have, well, I actually boiled it down to only what we really need, so not even Java EE, but like the individual standards like CDI, JAX-RS, and whatever. And I have microprofile open tracing, and that's, well, a Liberty-specific implementation for that. So with these things, I don't need to configure anything in my code. I just, well, make it work by configuring the server like that, and we will know about the open tracing standard. So that's great, and then all of these observability examples work, as you can see. Okay, awesome. Now, which other things do we have in our Istio environment? So what we can also have is some more resiliency. So for example, to answer the question, what happens if this connection breaks down or if the Barista application actually becomes unavailable? And there are a few, well, concerns how to deal with that. I mean, on the application side, we at some point have to deal with that situation. But even on things like connection-based timeouts or resiliency, retries, stuff like that. Luckily, what we do define in our Barista is we set some timeout, which is always a good idea, right? Otherwise, you might block or wait way too long. What we can also do, if our technology would not support that we could define a timeout on the connection level, actually on the Istio environment. And in order to do so, let me show you some Istio resources, some more YAML, yay. So this is actually the default way how to configure these Istio proxies. There are a few more resources and resource types. For example, virtual service, we have a destination rules, stuff like that. So what that is, a virtual service basically defines the traffic routing rules for a particular service that's part of the mesh. So this one is pretty boring. It says, well, everything that looks up the Barista host, please route that to, oh, the Barista host. Okay, that's the default routing. That's okay. And then we have furthermore destination rules that on the destination side might specify some policies. For example, who even might call this service, this particular instance, and things like that. So that's also the default, and it provides some subsets which we will use in a second. So to further split up maybe the traffic or the implementations of a specific service. So that can be quite interesting as well. And what we can do, let's go to the other one. Sorry, is there a question? Okay, so what we also have on the coffee shop side is a gateway here. That is basically the traffic ingress into the cluster, and that is being routed to a virtual service as well. Ends up at coffee shop, and so on and so forth. And what we can do here, we can add some more concerns on these routing rules. For example, resiliency, timeouts. What I will do is I define a timeout of 1 second, for example, that will be added to this particular arrow, to this particular route, specifically this one. That's the route into our coffee shop, and this one will now be guarded, if you want, with a timeout of 1 second. Okay, Now, who raised their hands when I ask about YAML? Who likes YAML? So the problem I have with that, how do you actually know whether this particular notation is correct? Or maybe this is correct? Or maybe this is correct? Well, no, this is correct.
Autocomplete.
Autocomplete, yeah, that's a good way. Actually, there is an autocomplete feature for, good point, for Kubernetes. So, for IntelliJ. So this one knows about these, yes, but it doesn't know about Istio yet. I'm sorry, it doesn't work. So you would need to let it know. Somebody else mentioned if you have a ruler in front of your monitor, so what you would need to do, so just place it here and then you know how to intend it. Well, anyway, okay. What I'm going to do, I'm going to update this with my example, so that still runs and creates some coffee. And what I say, okay, please apply now this deployment routing, these changes, and then it will hopefully say, okay, this one has been configured. That's another nice story about this Istio. So as you see in the YAML, they pretty much look like Kubernetes resources. Actually, they are, because Istio extends the API model of Kubernetes, and we can use them in the same way as if they were Kubernetes resources. So for example, we have, kubectl get services, right? And in the same way, where we also can define kubectl get virtual services, which are the virtual services of Istio. So in a default Kubernetes cluster, this would not work, but here, luckily, since that is a nice extension, we can use them in the same look and feel, and also use kubectl, like I just did with kubectl apply. And now, as you can see, well, it works, right? Timeout works. I mean, we don't get the timeout here, but, well, how to test that actually? I just applied the timeout for 1 second, and obviously that's faster than 1 second. But how to test the timeout? Well, what we could do is we go to our service deployment and say, now the barista application or anything inside has to slow down for testing purposes in order to see whether we defined our timeout correctly, right? Always test your resiliency approaches. So what we could do is redeploy something here to make that slower, to do something like a thread sleep or whatever. But that's also pretty bad, right? What we could do also instead, for testing purposes, is since we have the full control over all these proxies, they can mess things up on purpose, right? So for example, testing purposes, what we can do is to insert some faults. Just because we can. We say, hey, dear proxy, just please mess up something in that communication. Make it slower or make it fail, because we can. For example, insert a delay, something like a fixed delay, for example, 3 seconds, but not in all the cases, but only in 50% of the cases. Okay, that looks good. Ready for production, right? Let's apply this. What I'm gonna make is, I'm gonna make the other component slower, or actually the other connection. I'm just gonna slow that down. But what we see, we don't see a delay for 3 seconds. We actually see a delay for 1 second in these cases, and then we get a timeout. So then the timeout from the first rule that we defined, and that is the first proxy that actually times out here. So this is how to, well, define a few of the resiliency concepts. Same for retries, same for the circuit breakers, all HTTP connection based, right? And also how to test these resiliency things. So that is quite helpful actually in test environments. If you need to just make something fail on purpose in order to test your test or to test a scenario, then Istio is also quite helpful. So this is already a beginning of some more advanced traffic management. What we can do, we can use all of these rules and some more advanced ways how these services connect inside our service mesh. So for example, what we could say, well, just for fun, in this particular case, for some circumstances, please don't route the default way to this barista service, but route somewhere else. Or maybe route to a subset of that service that we might want to use for other things. So for example, there are some more advanced deployment approaches out there, such as A/B testing or canary releases, where we can actually use some of these approaches here. So what I'm going to do, I'm going to live code YAML a little bit more. talking about being brave or being stupid, depends. What we can do, for example, we can have some A/B testing approach in this coffee shop. So if we say, how about we take a particular subset of our users, those who use X, or however you want to specify them, and now take that traffic and route it somewhere else. So since the proxies are aware of HTTP, what we can use is all of the information that we have in an HTTP request. We can take that information and then use it to, well, route them somewhere else. So for example, what we can do is having a match, we're going to match a particular request with a higher precedence of the default and then the default case. For example, we can take the HTTP headers and look into particular headers, let's say such as user agent, right, or whatever you want to define, might be a custom one. And then in this case, we search for a regex, in this case, for Firefox browser, just for the example. And then what we're going to do, we're going to route this somewhere else. So this particular case will be routed not to subset v1, but v2 actually. So let's say we define another subset here that we route somewhere else. And then of course we have to specify that subset down here. So in this case we say, oh, we have instead of v1 also v2, or however you want to call it. And then this routes somewhere else. Now, how does this work? Where does the v2 come from? Well, of course, I have the coffee shop deployment that I showed you before, and that uses Kubernetes labels. Label version v1, right? And accordingly, I also have another deployment with label version v2. You have already seen that. If I say Kubernetes get pods, then we have a pod that's been created from another deployment. And we can route to that as well. All right, now in this case, what we can do, we can apply now this routing logic again. Anything that has Firefox, talking about A/B testing, a particular subset of our users will be routed here, and the rest will be routed to the default case. So let's stop this. Kube control apply coffee shop deployment routing. And then we reconfigure that. And now in our case, what we can do, curl, let's ask for this. What we say, well, here we get the default response with all of our coffee that we have. But now if we will provide, and only if we will provide a particular header, namely user agent, Firefox, then in this case, well, we get a different response, which is an empty response. That is the empty response of the other service that actually, or the other application, the other instance that has not been used yet. Okay, so what that means, well, now we could actually create some coffee here as well. So provide some espresso, for example, and create that here, and then we get this response back, or the default one, depending on which information we have. So we can switch that actually. And that can be made on all kind of information that you find in the HTTP header. So, or in the HTTP request actually. What we can do as well is to have multiple destinations for a particular route. So for example, for canary releases, where we say, well, all of our users, we just split them up, and a specific percentage will be routed to a different version. So for example, we can have subset v1 and v2 at the same time, and then we can even define some weight, where we say only 30% of this will be routed here, and 70% will be routed there. And then accordingly, let's update this again. And let's ask for, no, where is it? Firefox. Yeah, let's ask for the coffee here. And now, as you can see, this is the old response, the 70% that we get. And now sometimes you get a new response that actually only has this one coffee and answers a little bit differently. This now has a hypermedia link here as well. And this is how we can route that traffic. So why is that useful, or how is that useful? Well, as I mentioned, for A/B testing purposes, we could set that up manually, or we can control that here. But typically what you do, especially as enterprise developers, you are not as crazy as I am and live code this YAMLs and change it and throw it against a cluster. This is quite error prone and not really the best way. What we would do instead is actually set up some automation that does that for us. So for example, in your continuous delivery approach, if you want to deploy your software, you say, okay, I don't want to have just a big bang approach, but I want to gradually deploy my software. For example, only route 5% of the users first, see whether that works, or if that new version immediately blows up. And then if it works, you can increase that traffic, 10%, 25%, and then until all of the users get the new version, and you can shut down the old version in an automated way. And with the monitoring that you have in place, you can also see, whether that works and include that in your automation. So let me quickly demo that, how that could look. In this case, let me delete the coffee shop stuff again. And because we're going to apply another one, deployment canary release, where I say deployment v1, where I actually have some template here, these YAML resources as a template, where I can define, well, so and so many subsets do I have now, and so on and so forth. You will see I can provide the code to you later on, and where you see this looks something like follows. We just specify, multiple things that we can exchange later on. And what I do in this case, I see that I now have this version v1 here available, and I can actually ask for a health check here. Where is it? So what I have, let me have a look at that so that you can see this. I have a health check in my application that actually tells me the app version. Where does that come from? From another microprofile project that is called Hello Cookie Manager. That's not what I wanted. Health resource. This is a health check that is actually being used from my Istio and from my Kubernetes environment. That is application code that just provides, okay, I'm ready, and that's it. And it tells us that for that application, and I can add some more information here, some more metadata. So in this case, what I do, I simply say, okay, please provide that application version. So now it's always version 1, right? Version 1.1.1.1. And now what I do in this case, I go here and say, okay, deploy the canary release of old version is v1, new version is v2, and new image is v2. And then in this case, what it does, well, just what I told you before, it will deploy that new version as a new Kubernetes deployment that has different labels, but it will be routed by the same Kubernetes service. And once that is deployed, it will automatically take that Istio routing approach and route that traffic accordingly. So these 5% and so on and so forth. And at the same time, of course, zero downtime, our application stays intact and will respond the whole time. In this case, well, with version v1. So once that is up and running and being rolled out, then it will gradually increase the traffic here from 5% to more. And then you can see that you slowly get more and more responses from version v2 until, well, that is fully rolled out with that approach. And what you then can see, since we have a monitoring in place, is that now, let's go to the barista, the coffee shop one, with all these request volume that we also see, well, here, for example, we have incoming requests where now the v2 version gradually ramps up and overtakes the v1 version. And of course, we can see, well, what is the response here? Does it immediately blow up and crashes and burns? Well, then we could include that in our automation and roll it back, and so on and so forth. In the same way, what you see here in Kiali, now it's a little bit more interesting. What we see that we now have two different versions, a subset of coffee shop, and this is actually an old version here, as well, since that now doesn't even call barista at the moment. But you see that two versions are being called, and then at some point this will also change dynamically. So this is now the current picture here, since we do not create new coffee, so that will disappear soon. And we will see how that is being rolled out, and now it's being fully rolled out. We only have version 2 now. And that is one way how to, well, deal with that automatically, how to roll out software using this Istio routing here. There are a lot of approaches like that available. This approach, what is nice about it, it works inside the cluster. So even cluster internal services, where they're not even accessible from the outside, can be rerouted accordingly. And then other Kubernetes services will call them accordingly. So that's another thing that is available here and that I find quite interesting for the networking part. So if you're interested in that, I will provide all these resources. What else I recorded sometime last year was actually a video how to explain all of these networking resources in Istio, because I found that actually quite hard to get at the first time. So what is the difference between a virtual service, a destination rule, especially since last year at some point the API changed, and a gateway, and when to use which, and so on and so forth, and what is possible there. So if you're interested in that, you can have a look at this. What else I want to quickly show you is a deployment for. Let's roll this back. If we have time, delete. I'm gonna delete that deployment of Coffee Shop. Again, the V2 Coffee Shop, and what I'm going to do then, I'm roll this back for the deployment here, and I'm going to show you one particular thing that is called Telepresence, which doesn't have to do much with service meshes in Istio, but Kubernetes actually, which is a debug or testing tool where we can replace deployments or instances, pods inside your Kubernetes cluster with processes that run on your computer for testing purposes. So you can make your laptop part of the Kubernetes cluster, kind of, and then run stuff locally, where you can quickly redeploy things that run locally as a process, or where you can debug things locally. And actually a proxy on the Kubernetes side, a Telepresence proxy, will make sure that it's being rerouted. And thanks to Istio, you will see the same observability and everything that you have there, and it will work just as well. So what you can do here is fire up that's Telepresence that actually uses another tool where I can quickly redeploy something using Java Enterprise. And what it will do now, it will actually replace my Coffee Shop pod here with, well, something that, did I roll back my virtual service here? Actually, let's do this. Otherwise, I will get other different artifacts. Let's apply this quickly, deployment. And now what I have here, in my cluster, I will have a proxy, a Telepresence proxy, and locally, what I will have, I have a Docker container that runs locally on my laptop. And that is now being replaced to whatever runs in that cluster. So for example, what I can say, health, yes. This, no, this now uses a different health check. This one. Let's do it without the while true. So now this accesses the application, the health check here, but actually what it does, it accesses the application that runs locally. And now thanks to that redeployment routine I have running here, I can actually go to my health check resource and say, well, app version so-and-so. What I can do in this case, I can say with data, hello Riga. And it will modify and reload that thing that is running in my local Docker process. And then I can say, oh, now I access this that is actually running in that cluster. And it says, did I use the correct one? A second call localhost, so locally that runs health check. Yes, this one runs here locally. Curl, let's get the IP address here. And this, nope, oops, will now say, okay, that didn't quite. Oh, because of the routing. I'm pretty sure that routes to the other version here. Yes, let's delete that as well. It's the routing here to subset v1. So that should work. Let's reapply this. And let's see, well, how that works. Okay, anyway. But in this case, this is how you can actually take something that is running in part of the Kubernetes cluster and, well, replace it with something locally for testing purposes. So that's very helpful in this case. So as a takeaway for service meshes, for Istio particularly, what service meshes do, they transparently add these cross-cutting concerns that we might need in a production setup, such as resiliency, observability, advanced traffic management, and so on and so forth, without changing our applications, right? All of that is still running the Java Enterprise approach with some micro-profile additions, and all of that is being added by the environment here. And I think this matches the Java Enterprise approach very well, because as developers, what we should care about is how to implement business logic, right, in Java. So that is what we should care about, and it's the same is true for Java Enterprise, right? How do we access a database or manage transactions or HTTP handling? Well, the answer is we don't. The application server provides that for us, right? In a different abstraction layer, and that is being implemented somewhere else. And now the same is true for all of these concerns. We don't even have to ship them in the application that we deploy somewhere in our jar file or WAR file or somewhere. That is now also being provided somewhere else from outside, from the environment, from our service mesh. And as developers, that means we can then focus on what we should focus on a little bit more. That is implementing business logic. I hope that was helpful. Thanks a lot for your attention.